Hello, and welcome to 2D Best Practice in Unity. My name is Veli, and I work at Unity as a 2D engineer. So my responsibilities are mostly on the complete workflow, import pipeline, the editors, there's the sprite editors, collider editors, how you are supposed to make 2D content and games completely, and a little bit on animation tools as well. So I'm doing the animation editor and some new animation tools as well. So this talk about is how to really make 2D games. I think most of you have already at least tried or checked out what the 2D is all about. And there's a lot of concepts that are not that clear as a first-time user. There's things that get linked very far away into production, some like very early in the productions. If you get some things wrong early, then you have some problems later on. So we are trying to look at those different issues. And we have a set of topics for today. There's a 2D skeletal animation workflow. So I'm showing how to make a complete 2D character with bones, with inverse kinematics. So there's a sprite animation reskinning that we're going to talk about as well. There's isometric sorting and camera scaling. And we should start with the 2D skeletal animation. So we take a look at how to create the hierarchy, set the sorting right. Also, there's a simple CCD, this inverse kinematics solver for that. And I will share all of this source code and tools today for you guys, just to hack around it and learn something about that. And then we're checking out how to use the animation events to synchronize the sound effects or any arbitrary code that you want to play. So let's start with Unity. And so we are aiming to create something like this. So we have a 2D character. There's IK targets for the character itself and some animation done as well. So let's take a look how to make a character like this. So let's create a new scene first. So in this case, we started by having a sprite sheet. Let's open it up a little bit. So in this case, there's a sprite sheet with all the parts for the character. And first thing you have to do is to set it to multiple mode. Go to sprite editor, slice everything up. Then its important part is to name everything right. So here you have the, for example, upper body. There's a head sprite. There is a shoe, a left leg, right leg, and so forth. So that's the first thing, to have a convention for names, because when you are sharing animations later on with different characters, you want to have all the part names to be the same. The next thing you have to define is the pivot points for the sprites. And the pivot point is it's like the center of the sprite itself. So when you rotate a sprite, it will rotate around this pivot point. So for body part for the upper body is probably down here. For the head, it's also a bit lower. And for the shoe, it's going to probably be somewhere around here. But this is something you work with your artist, like how to set everything on the right places, how it should actually rotate. So I'm not going to do all of that right now, because I will take too much time. So I have prepared a ready one. And here we have all the different sprites already named and set the pivot points right. So the next step is to actually create a character, just get all the pieces to the scene, to the hierarchy. And what I think is a good workflow for that is to start, in this case, from just laying all the parts in the scene. So let's start with the torso. There's a lower torso. There's a lower torso pants. There's upper torso as well. So it's first start by just setting all the pieces around where they should be visually. Then go with left thigh, left front sleeve, left lower leg, and so forth. And then just setting them to correct positions. Left shoe as well. So at this point, you can see this pivot point for this bone sprite. It's in that position when you rotate, it rotates around that part. And the next part is to set the hierarchy right. So with the characters, it's very common to start with the hip. So that's just moving the game object around the hierarchy view. So we start with the lower torso pants, maybe in this case. And that's our parent one. So we move the lower torso under that, also the upper torso. And then we put the left thigh, and we want to have the lower parts as a child of that, the pant sleeve, the left thigh, and the left shoe around the lower leg. So this way you create the hierarchy, the kind of the armature for the game object. So now if you move the upper part, it will move the lower part as well. And next one is, you will get problems is the sorting, to get the sorting order right. It could be that when you are setting up, for example, if we add now the right, let's see, the right leg part in here, we can notice that it actually gets rendered on top of the other leg, but we would have to have this to behind. So in that case, we have to change the order and layer for that. The workflow of that is a bit hacky. It's usually what I do is I start with the kind of middle point of the character. So that's the 0. That's the order and layer. It would be 0. And when I travel more far in the hierarchy, for example, for the left thigh, that will be the next step in the hierarchy. So it will be 10. And the next one will be 10, to be 20, and 30 afterwards. And then fixing it afterwards, if you notice that the sprites are clipping each other and so forth. So I have a prefab for this, that everything is set right already. So let's see how it will look later on. So here. So can actually remove those as well. So for the animation, now we have all the parts set up right. You can see that there's correct rotations, like the hierarchy is correct for everything. If I select the upper body, only the upper body will rotate, also the head as well. And what's important for the animation, when you start to animate, is to have all of these sprites being a child of our empty game object. Because then you can, if you animate something in the child object itself, they don't affect the movement of your character. Maybe you move your character by using physics or just using a custom script character controller to move it around. So the next part is to actually have the inverse kinematics. because now it's pretty hard to animate if we would like to have the character bouncing around or doing whatever in there. So then you have to exactly match the shoe positions, the leg positions, and using like what's called a forward kinematics, just moving those bones around, it's very hard to get that right. So there's a very simple system I did. It's a simple piece of code I will share with you later. Like there's the download link in the end of slides. And for that one, let's take the arm. And actually, there's something happening there. And add a component to it. It's called a simple CCD. There's a couple attributes. First is iterations. And because these are real-time IK solving, it takes in some iterations to get everything solved out. So this is it means that it takes 5 iterations per frame at the moment. The next one is damping. I will explain that a bit later on. And then we have 2 transforms. There's a target and an end transform. So the target is where we would like to have the IK solving chain eventually, to reach. So let's create that first. So let's just create an empty game object in here and call it just target in this case. And so that we could get it actually easier to select it, we will change the icon to a name tag. So now it's easy to select from here. And with the arm, let's drag and drop that to the target. The second one we need is the end transform of the hierarchy. So in the end of this hierarchy chain, we have the right hand. There's just an empty game object. It's kind of trying to be like the palm of the hand. And we will drag and drop that to the end transform. And now we have the IK system already working in there. And what we can notice that, okay, it can rotate to wrong directions. So that's something that we can fix really easily. There's angle limits on the component as well. So let's add an angle limit to right lower arm. That's in the middle of the chain. Drag it in there. Then we have our gizmo on the scene. And now we just try to find the correct limits. So it's around from 30 to like 150 degrees, yes. And now if I move the target point, it will actually limit the rotation of the sprites. And that we should do like for all the objects that we want to have. Usually it's arms, legs, maybe a head, maybe some other parts, depending how many arms, legs, or other things you have on the character. So there's a ready one. There's all the angle limits set it up. There's different targets for both arms. Can remove that one. And also for the legs as well. Just a moment. So with this working on, we can start doing animations for the character. So if we look at the hierarchy right now, we have the empty game object. There is an animator component. All the sprites are under one game object. And there's another game object called IK, where we have all the targets. We want to have all the targets for the animation as a child objects of this main one. So let's open up animation window. You can find it from the top. It's a window and animation. And let's create a new clip. Call it idle. On this case, because how the IK works, because this is made with a public API, and it's not a like really internal tool, is that we will override whatever the animation system does in Unity. So there's a couple things. First thing is that if I animate the character arms that are in the IK chain, they will not get animated straightforwardly. Instead, I have to animate target points. So because now all these bones target to a certain point, I can actually take the, for example, from here, select the hip. Is it there? Bottom body. And if I just move this game object around, all the arms and legs are trying to get to a correct position. So this makes the animating much, much more easier. So for a very simple up-down animation, we would just select a frame first, go to 20 frames, move the body down a little bit, and now we can see there's 2 keyframes added in here. And then we select the first one, copy it, just pressing Command C, and paste it by Command V. And we have kind of 2 hold keyframes. So the starting and ending keyframe is the same. And now if we are playing it, you can notice that okay, the arms and legs are keeping their position. But still, it's a bit, the middle part of the animation is very smooth, but the ending parts are a bit tacky, but that's very easy to fix. So you can select all the keyframes, right-click, and set them as a flat. So this will change how the curves are, the curve shape we have for the position. So now it's much smoother animation. And for animating the arm positions, for that we can go to, for example, in the first frame, we would like to have the arm in here. And on the next frame, have the arm on some other position. So now we're just animating the target points, but because the IK system will override all the movement after the animation system, so it works pretty nicely. Sometimes it's useful not to have the IK system on while making animation. Sometimes you just have, it's easy to make a forward kinematic animation for some parts. For that, you can actually disable components by using the animation system as well. So if we would like to not to have this IK solving on the animation, we will go to the first frame and just, while on the record mode, we just disable the component. And now we can see there's actual Boolean toggle in here. You can enable or disable single components. So in this case, the IK system doesn't do anything anymore in the animation. So there's some things on sorting that you will end up having problems. Then now you have your character animated, and you have the IK system, so you can make the character to reach different objects or climb, all kind of stuff. But then you end up having this problem that you maybe have more characters in the game than just one. So if I duplicate this one, so I instantiated a new character to the scene. So what you end up having is this, that they are not actually in back or in front of each other, because they are using the order in layer number, but they are actually on the same sorting layer, But what if you want to have 50, 100 characters? You will end up having problems like, everything is kind of partly on the back, partly on the front. There's a very simple fix to do that. And there's a script here. Let's take a look at it. It's called increase sorting order. And what it does is a simple monobehavior. There's a static int, that's the render order offset. And because we can use very large numbers on the sorting order, so what we do is that we will, on the start, we will increase the amount by some value, big enough, and then go through every renderer in the character. There could be sprite renderers, there could be mesh renderers. In this case, the character is using particles for the hair, so it affects those as well. And then it will add just a value in there. And when you hit the play mode, we can see it now. We can move the characters around on top of each other, and they will get rendered correctly, either in top of them, each other, or the back. And like I said, that it's actually affecting all the renderers. So with the sprite renderer, we have exposed the sorting layer and also the ordering layer. But this is actually for everything. So even the particles that we are rendering here. So skinned mesh renderer, they all have sorting layer and a sorting order. And you can actually use that in 3D games as well, or 2D, 3D hybrids. There's a couple things let's take a look at. One is the simple CCD, the component itself. And it's a monobehavior. The only difference to like normal monobehaviors, it has this attribute called execute in edit mode. And what it does is that if you have update function, start function, they will get run in the editor as well, even if you're not in play mode. There's a little trick in there as well. There's a onValidate function, and this function is called if you change something on the inspector itself. So if you fiddle around the numbers, any parameters, this will always get called in the editor. So this way you can make sure that all the numbers you have for the component are same. I don't go through all of this, what this component actually does. It's not much of code. There's a little bit of math for doing the IK solving right. And there's one value that's something I will probably explain on a blog post later on, is the damping that we have for the component. And it kind of, if you have very long chain of IK, let's say like 5 to 10 objects, but you don't want to kind of divide the amount of rotation between them. But this is something you can just fiddle around and what feels right. And then for this tool, we also have the angle limit gizmos. I'm using a little editor hack for it. If there's any editor programmers here, maybe somebody will get something out of it. It's a simple CCD editor. So this one is just a simple class. It's not an editor class. It's not an editor window or anything else. It has a special attribute called initialize on load and a static constructor. And every time if you compile some of your scripts or you start Unity, this will be run immediately. And then we have an on-scene function in here, and it gets registered on the static constructor. So now even if you don't have anything selected in the scene, this will still be running. And then you can just use the normal handles, whatever on-scene code you want to make all kind of special tools inside of the editor. That's about for the IK tools and IK animation, how to make character. There's one little thing I actually forgot to mention is how to synchronize the sound effects or some code in the animation. So maybe there's a walk cycle animation, you want to have an exact moment to have a step sound. And for that, we just select the frame. We want to have the sound effect. There's the button called Add Event. We click that. And there's a drop-down after this one. And if you have any scripts on the game object that has the animator, you can actually call those functions from here. So in our case, we have play audio clip. And then I can drag an audio clip from the project in here. And this is there's an animation event example on the same game object as the animator is on. And if you look at it, it's a simple mono behavior. There's the play audio clip function, and it takes an asset as a attribute. And then we can just play the audio source, play the audio clip, or if not, then just do whatever we want, maybe some debug error, or at the same time, just maybe add some particles, emit some particles, some other VFX. And it can be any kind of code that you can run through that. So that's for the animations, the skeleton animation. And let's go forward and go with the sprite animation reskinning. And this is like, when you have, this is very much like for, you could have different looking characters a lot in the game. You have a wizard, there's maybe a warrior, there's a warlock, whatever, trolls, and you want to make some animation clips for them. So you end up having, you make a character, you have 10 animation clips, then you have a controller for them, you have a state machine, everything is going on very nicely, but then you figure out, oh, I actually have to make more characters. Okay. Let's try to keep this on somehow. So you need to make more characters, but if you're using sprite frame animations, you notice that, okay, the sprite frame animations actually, the whole sprite animation is in the animation clip. And then you have a problem of reusing all the controllers. There are a couple ways to do that. One is to use the controller override, and I will show you a different way to do it. I kind of like it because then you don't have to create this hierarchy for every game or every character. So let's go to reskinning. Here we have this cute little character. And if we hit the play mode, there's an animation for it. And again, we have the armature in here. There's the head, arm, left and right foot, and so forth. And there's a game object, component in the main game object that's called reskin animation. And there's a sprite sheet name here, and that's a character 1. So if I change it to character 2, character 3, or character 4, I will get different looking skins. And for this to work in the runtime and in the editor as well, we are using a resources folder for that. And on the resources folder, there's the 4 different characters. The resources folder is a special case inside of Unity. So whatever you have in that folder will get included in the game. If you build a game, all those assets will be there, even if you use them or not. So that's something you have to make sure you clean it afterwards if there's some temporary files. But there's 4 sprite sheets in here, and they all have similar name parts, and they are about the same size. The pivots are about the same places as well. It's around there, so it usually works pretty fine. But the most important part to have is to have the same naming. And when we are on the play mode and we have the animation running on there, we will swap the sprites by the name. So let's look how to do it in the code. We have a simple mono behavior for that. There's the Sprite Sheet name. And the first thing is to load all the sprites under the Sprite Sheet. So for that, I'm using resources, load all sprites, and then giving the path to the actual Sprite Sheet. So there's the folder name, the characters, and the Sprite Sheet name. And by this, we will get all the sprites that are in there. Then we will go through all the child objects in the character and get all the renderers, and then find from this array of sprites that we just loaded, we'll find if there's a same named sprite in there. And if we actually find it, then we will assign it to the renderer. And this is done in the late update. And because on the animation system, the animation gets sampled between update and a late update. So if you do this in the update, then the animation system actually will flip the animation in the clip back in. So we have to use a late update for that. And probably all the programmers in the room notice that this is the most horrible way to do this. And also this one in here as well on every update. But it's just for like having a simple example how to do it. Of course, you will hash all of those and use a dictionary or something else to do that. So this way you can easily share the kind of the armatures, the controllers as well, and swap the looks of the character very fast, very easily. And you don't have to use Sprite Sheet for that. You can just use single image sprites, and then instead of loading from there, you just drag them as an array to your component that does this same flipping method. And that's about the reskinning parts. And let's go forward. It's a lot of content I'm trying to cover. Isometric sorting. So using the 2D sorting system is very nice if you're doing a side view or a top-down game. But if you want to do something else, like SimCity, for example, old school SimCity, then you will hit that problem that, okay, you have to use like depth sorting or something similar to get all the objects in right places. So you can actually use the sorting order for that. So let's take a look at it. There's a couple other nice things in there as well. So let's go to the isometric sorting scene. And here I have this apartment scene. It's not really sideways, not really top-down either, so it's like in the middle of those two things. And let's select a single sprite from here, the fridge. And if I move this around in here, it gets sorted by the height, like where it's based. So if I'm putting it like back of the table, I'm expecting it to be rendered before the table. And if I move it in down here, it will get rendered after the table. So what we can notice is that when I'm moving the vertical position, the order in layer is changing as well. So the more lower I go, the higher the order is. So let's, wrong clicky here. Okay. So again, there's a mono behavior with the executing edit mode, so it's like easier to smoother to work in the editor. There's an update, and then we just simply take the vertical position of the object, multiply it by a negative value, because we want to have like the top object to be in the back. And in this case, I'm just using number -10 because it makes sense for this game. But this all depends on what's your scale of your game. So it could be -1, -10, -1000, 0.1. And you can also, if you want to make this sorting order like what SimCity has, for example, from the top right to bottom left order, then you just use the vertical and horizontal position to calculate the sorting order. And then you will get nice sorting and don't have to care much about it. Of course, you probably don't want to do this for every update for static objects, but instead have a single manager that finds all the sprites in the scene and sets the correct values, or maybe it's just an editor tool that makes it. And these are very nice hacky, like not hacky, this is like kind of designed for to do that, but and you don't. It's really fast to change the sorting order value, and it's really fast to do the sorting that way. So you should really use it. But what you end up having problem is that if I would like to move this, for example, this sink on top of the cabin here, it will of course get back in there because of the position. So there's two ways to fix that. One is to set the sorting layer to be front. So in this case, a foreground. So now all of the foreground objects only affects this one. Or other way to do this is to go to Sprite and change the pivot. So we go to Sprite Editor, we move the pivot down and apply. And now we can move it on top of here. Because the pivot point, since that's the center of the sprite game object, so it will define the ordering in this case. And since we have lots of time still, go to camera scaling. Camera scaling. This is something it's kind of hard in Unity at the moment. If you are making any kind of game, is it 2D or 3D game? But we just look at the problems with the 2D. You could have multiple aspect ratios, resolutions. You have landscape, portrait modes for the games, and it's really a hassle to work with the scaling. By default, Unity kind of scales the content by the height of the screen. I will show a simple, what I actually mean by that. There's a couple of formulas in here on the screen, and they don't really make sense, quite not yet, but let's try to look at what they actually mean. So let's go to camera scaling scene, and we have the same apartment here again. But if you go to the game view, and let's set some resolution here, okay? So in 2D, you easily use the orthographic projection, and for that you have the size. And for example, if I set this apartment to feel like the vertical space of the screen, and now change the aspect ratio and resolution to something else, for example, iPhone 5 resolution, you can notice that, okay, it actually kept the height scaling, but from the sides, the image got cropped. But that's something you not always want. And other thing is that it's very hard to define that you have a certain resolution and your sprites are a certain size. So maybe you want to make a pixel perfect sprites. You want to make a sprite to be maybe 10 pixels per pixel and stuff like that. So there's two components in here. First one is a pixel density camera. So let's enable that. And there's a pixels to unit. Let's set it 100. So now we have very big pixels on the screen. And if I change, for example, a free aspect, we can notice that it didn't actually scale at all. It just tries to keep the amount of pixels on the screen always the same. So then we get these kind of windows that we are looking through. This is very handy for many kind of games or effects. And in this case, if you want to make it pixel perfect, there's a couple things you have to try to match. One is the position of the sprites and stuff like that. But first one is to get this one right. And in this scene, in this project, all the sprites are in here, are using, on the importer, they're using pixels to unit size 10. So as long as all the objects in the scene, all the sprites are using pixels to unit 10, then I can just put 10 in here, and everything will be pixel perfect. You know, it doesn't matter what resolution I'm using, it's always the same pixel perfect size. And let's look at the actual code that does that. There's again a mono behavior. There's the nice attribute there as well. And there's the update. And the orthographic size is the size that we change on the camera component. And we calculate it by the screen height divided by the pixels to unit divided by 2. So this way you can calculate kind of the pixel density for the screen for the current resolution. So the next one, let's select the iPhone 5 resolution. This is a very common problem that maybe you want to have a game look like this, that you have the side of this apartment to feel like the side of your actual screen and the phone. But when you move to, for example, iPad, this is what happens. You will get extra space on the side, and then you have to figure out how to zoom back in and keep that. So let's go back to iPhone resolution. And there's another component, scale width camera. So let's enable that. There's two values in here. First one is the target width. So this is like the virtual resolution. And because we want to target as a main platform kind of thing, is the iPhone 5. So it's on iPhone 5 in this resolution, the pixels to units is around 20 to match the size. So in this case, if you change back to iPad, and let's update this, then it will use the iPhone 5, the 640 pixel density as a reference on how much pixel density should be on this screen, on this platform. So now if we change to complete sideway, it's the same thing. It will zoom the camera in to feel the width of the content. And for that, it's pretty much the same code that there was before. There's the size is the height divided by pixels to unit divided by 2. But for the height, we have to actually calculate it from the original target width. So it's kind of a virtual resolution that we are calculating for these values. So at this point, these formulas kind of make a bit more sense. And yeah, that's actually pretty much it. You can download these examples using that URL. So there's the IK tool, the editor, the whole project files, all the scripts, and there's my Twitter account as well. So I will be posting, if you have any kind of questions, you can just tweet me. We have a couple microphones in here for questions as well. And if you don't want to really ask right now, we are having a hands-on lab the whole day today, and you can just pop in any kind of 2D questions you have. Just come over, and you can just bring your own laptop with your game if you have some kind of problem that you don't know how to actually figure out how to do it or how to automate something. Then just pop in and ask some questions.